Hello, Calculus 12, and welcome to 5.4, which is applications of sinusoidal functions. What this means is we're going to be looking at word problems that involve sine and cosine functions today. There are two main types you're going to see. One, which you can see on the page here, is Ferris wheel questions, and the other one is tidal wave questions, like in the ocean. So once you do a couple of these, they really all start to look the same. But we're going to go through how you can set these up and graph them and solve. Okay. I find it helpful to draw myself a little picture. So I'm going to actually draw myself a Ferris wheel. And I'm going to use that and pick out some key points that will help me both graph and write my equation, right? Now, many of these equations you would be able to write as a sine or cosine graph. And again, remember that when you do that, the only thing that will change between the two is the phase shift. So regardless of how you write your function, your amplitude, period, and displacement should be the same. The only thing that would be different would be our phase shift. So for this, the question, we have a Ferris wheel with a radius of 42. I'm going to actually draw myself a Ferris wheel. And this Ferris wheel has a radius of 42 meters. Now it tells me that the center is 43 meters above the ground. So what that tells me is that there's an extra meter at the bottom here before I would have the ground. And that would give me 43 meters total. And it's telling me it rotates once every 50 seconds. So that's going to be my cycle. So that means that my period is 50 seconds. Remember, that is not your B value, but it will help us find our B value. Okay. If I want to find my B value, I know that my period, which is 50 seconds, is equal to 2 pi over B. I could rearrange this so that I have 50B equals 2 pi, or B equals 2 pi over 50. And I can simplify this to be B equals pi over 25. That's going to help us for part B. For part A, we do just need to know the period. Okay. Now, it's also telling us that we're getting on at t equals 0. And it hasn't told us that we're getting on anywhere but the bottom. So we're going to assume we get on at the bottom of the Ferris wheel. So when I get on the Ferris wheel, at the beginning of one cycle, and my height would be 1 meter off the ground. Okay. And we would get back to a height of 1 meter after 50 seconds. Okay. Now, the question that we need to know how far the period is. We've got that 50 seconds. We need to know our minimum height. Well, if we're riding the Ferris wheel, our minimum height is 1. We need to know our maximum height. So when we are a full rotation around the Ferris wheel, we would reach a maximum height at the top of the Ferris wheel here, and then we'd go back down. And the question is, what is this height? Well, this height, right here at the top, would have to be the diameter of the circle plus that extra 1 meter at the bottom. So my height at the top is actually going to be 85 meters. Okay. So my maximum height would be when we've traveled halfway around the Ferris wheel, which means that my time would be 25. So if I want to draw this, I know that I need to have a y-axis up to at least 85, and I need to have an x-axis in increments of 50. But I also know it would be real helpful if I was able to divide my period in fours. So if I were to just use 5 boxes, the 50 seconds, each box being 10, 5 boxes being 50 is not great. It doesn't divide nicely. If I really had my way, I would want like 8 boxes to be 50, or I might want maybe 16 boxes to be 50. So if I do 8 boxes is 50, the only thing is 50 doesn't divide nicely by 8, but let's see, let's try it. 2, 4, 6, 8. If this is 50, that means my 25 is here, and this would be 12.5. Okay. Not terrible. We can make it work. And this is going to be 37.5. Okay. And then another 2, 4, 6, 8 boxes along, that would be 100. What will happen is if you don't pick a multiple of 4, it's fine, it'll work. It just means that some of your points will not be on axis lines, but that's totally okay. My height has to go up to 85, so 10s isn't going to work. 10, 20, 30, 40, 50. That'll only get us up to 60. So maybe I'll try 15s. All right, that works. So we are going to get on at time 0 with a height of 1, way down here. Not quite on the origin, but really because the one box is worth 15, it's pretty darn close. And then we finish the cycle after 50 seconds. We know that halfway between these two, at a time of 25, we have a height of 85. And it told us that it's a sinusoidal function. And so we know that if these are our minimums and our maximums, halfway between these points would be our midline. Okay? And if I take a look at my Ferris wheel here, my midline would go through the center of the Ferris wheel, which would be a height of 42. And when we're traveling around the Ferris wheel, if we get on at the bottom, when we travel around the Ferris wheel, we'll reach that midline after a quarter turn of the Ferris wheel. Then we'll reach the maximum after a half turn. We'll get back down to the midline after 3/4 of a turn, and we'll hit back at the bottom after a full turn. So we're going to reach that midline after a quarter turn and 3/4 of a turn, which would be those half points. So halfway between the minimum and the maximum that we just drew, which is 12.5 seconds, we have a point at 42. And halfway between the maximum and the minimum on the other side, we have a point of 42. And then we can draw in our curve. We can repeat this with another cycle. It told us to graph for 2 cycles. The next cycle would end after 100 seconds. The maximum goes halfway in between, up at 85, and the midline goes halfway between each of these. And we have 2 cycles. So you'll notice here, if we draw in some of these points, we've got our midline here. It's the center of the Ferris wheel. Okay, which is a distance of 42 from the minimum, but my total height here is 43 meters off the ground. We can see we have a period here of 50 seconds. And we can see we have our maximum and our minimum. My maximum is 85 and my minimum is 1. So this means that if my period is 50, we already found B. We're trying to write an equation as y equals A sine B x minus C plus D. Well, we can see that D is 43. My midline is 43 meters off the ground. So that's the distance the center is above the ground. My amplitude here is the radius of the Ferris wheel. From that center line, I'm traveling 42 meters above and 42 meters below. So this is the radius of the Ferris wheel. This will happen for all your Ferris wheel questions. For any Ferris wheel question, the amplitude should be the radius of the Ferris wheel. D is the distance from the bottom of the ground that the center of the Ferris wheel is. So the distance from the center of the wheel to the ground is your D value. Okay. We already found our period was 50 seconds. And this gave us that our B was pi over 25. So we already found all these things. So we already know that displacement's 43, amplitude's 42, our B is pi over 25. What we need is our C value. So if I take a look at this graph, I see a cosine graph that has been vertically reflected. However, it has specifically asked us for a sine graph. So if I see a sine graph here, remember a sine graph starts on your midline, goes up, then down, and back to the midline. So where I see a sine graph is right here. And what that means is that this is my C value. I would have moved to the right by 12.5 or a quarter turn. And if I look at the picture of my Ferris wheel, that makes sense because I know that sine starts on a midline. My midline is either a quarter turn or 3/4 turn. And for a sine graph, if I start on the midline, I go up first. So if I take a look at my two midline points on my Ferris wheel, here and here, on which point would I then go up first? Well, if I'm traveling this direction counterclockwise around, like I would travel around my quadrants, that means after a quarter turn, I go up. So therefore, I have all of my values here. I'm going to have y equals 42 sine, b is pi over 25, x minus 12.5 plus 43. And as long as you have a Ferris wheel question where you're getting on at the bottom, if you are asked to do a sine graph or a sine equation, then you will have a phase shift of a quarter turn. Okay. Sometimes they'll try and trip you up a bit and they'll tell you that you're doing a Ferris wheel question where you're getting on a platform so that you get on at that midline. And so you just, I would say graph it and it will really help you figure out if you have a phase shift or not. So the next type of question we are going to do is a tidal wave question. Okay. And it says at Seaport, the water has a maximum depth of 15 meters at 7 a.m. Okay. So I have, again, I find it helpful to draw a picture. Okay. So at 7 a.m., I have a depth of 15 meters. Okay. Then it's saying the minimum depth of 5 meters lower occurs 6.2 hours later. Okay. So I'm going to draw myself a little axis. So this is at 7 a.m. And this one here is 6.2 hours later. So this is at 13.2. If I did 7 plus 6.2, or 1:12 p.m. Okay. So the distance between here is 6.2 hours. Okay. I also know that up here, this is a maximum depth of 15, and this is a minimum depth of 5. So just a reminder, I have a sine or a cosine graph. I know a couple things. I know the distance from the maximum to the minimum, and then the minimum to the next maximum is half a cycle. And I also know the distance from one x-intercept to the next from my sine graph. These are also half cycles. So it's very important that you know what those basic graphs look like from 5.1 to 5.2, because that helps you with this question. Okay, so if I know where my maximum is and I know where my minimum is, I know that halfway between there, which would be at a depth 10 meters, halfway between the maximum and the minimum, I have a crossing point. Okay, so halfway between here, I have a crossing point. And since my cosine shows me that between my max and my min is half a cycle, that means this is half a cycle, and I would need to go another 6.2 hours to get my next maximum. And then halfway between there, I would have another cross. So what's the period of my function? Well, I know that my period from max to min is equal to 6.2 hours. So my full period is 12.4 hours. So you can't do this if you don't know those basic graphs. And if you don't, maximum to minimum is a half a period. So they're asking us to write an equation for the depth at any time t. So if I write an equation, one, I need to know my amplitude, period. Period will help me find my b value. I need to know my phase shift, and I need to know my displacement. I then need to also make a decision if I'm doing sine or cosine based on what I see, as well as my phase shift. Okay? So first, my amplitude, we can see from the picture, our amplitude here is 5. We can also see our displacement, or our midline, is 10. We know that our period is 12.4 hours, and we know that our period is 2 pi over b. That means that b is 2 pi over 12.4, which we can write as pi over 6.2. You can leave like that, or if you like, you can rewrite this so that you don't have a decimal on your denominator. If I don't want a decimal on my denominator, I would need to times that denominator by 5 so that I can get rid of the 0.2, which would give me 5 pi over 31. And any of these are fine. I would take any of these as your b value. Any of these are okay. It told us we have a sinusoidal function. That means either sine or cosine. I see this as a cosine graph. If you kept this going over this way, then you could see this as a sine graph, but I see a cosine graph that has been shifted right to 7 a.m. So if I see that, I'm going to have y equals, my a is 5. I'm going to use cosine. My b, I'm going to use the 5 pi over 31 because I don't like having decimals and fractions together if I don't have to. I'm going to have x minus 7 because I moved to the right by 7 hours. And then I'm going to have plus 10. Now it asks for the depth h in meters and time t hours. So the really mathematically correct way of doing this would be to not have a y and an x, but to have h equals 5 cosine 5 pi over 31 t minus 7 plus 10. And again, any of these b values you could have put into where I have my 5 pi over 10. Mathematically, they're all equal, so it would be the same. Also, if you chose to do this as a sine graph instead, you could. You would just have a different answer. Now it's asking what is the depth at 11 a.m. So this means that your time is 11 hours. So I'm going to have h equals 5 cosine 5 pi over 31, 11 minus 7 plus 10. And we're just waiting for some technical here. There we go. Now you want to make sure that your calculator's in radians mode and that pi is a good hint that we need to be in radians mode. And all of this stuff here over top of this red line is going to go into your calculator. So you really need to make sure you know how to use your calculator here. Mine pops up a bracket. So when I type this in, I would have 5 times cosine and a bracket would pop up. And then I would write 5 times pi divided by 31 times 4, because 11 minus 7 is 4, end bracket, and add 10. If yours does not come up with brackets, you might need to add them. You might also need to calculate all the stuff in the brackets first, then apply the cosine times by 5 and add 10. So you really need to make sure you know how your calculator works here. And if I plug all of this in, I'm going to get that h equals 7.8 meters. Now, the last question for today is asking us, what is one of the times when the water is 11 meters in depth? And the reason it's saying one of the times is if we look at the picture, 11 meters, it's going to happen over and over. 11 meters would be about here, here, here. It's going to keep happening. So we're just trying to find one of them. Okay. So one of the times when the water is 11 meters in depth. So I know that I have h equals 5 cosine 5 pi over 31 t minus 7 plus 10. And again, a reminder that this is all inside the cosine. And I've been told that the height is 11 meters. My depth is 11 meters. So I have 11 equals 5 cosine. I'm going to put big brackets here. 5 pi over 31 times t minus 7 plus 10. So my job is to find t. So before I can find t, I need to get cosine by itself. I'm going to move that 10 over. I'm going to get 1 equals 5 cosine 5 pi over 31 t minus 7. You can change the 5 pi over 31 to an actual number if you'd like not a fraction with pi. If you want to calculate what that is and put that in as a decimal there, if that helps you, you can. Then I need to divide by 5. Now, just a reminder, if I have something like cosine theta equals x, then I would have to do inverse cosine of x to give me theta. So I'm trying to find the theta here. Okay. So if I have, you can think of this as, if you want to, you can rewrite this. And you could rewrite this as a theta inside your cosine. So if it helps, what you can do is you can rewrite as h equals 5 cosine theta plus 10 and try and find theta. So I would get 11 equals 5 cosine theta plus 10, or 1 equals 5 cosine theta, or 1 over 5 equals cosine theta. And then I know that I would have to use inverse cosine to find the inside stuff. So I would need to do inverse cosine of 1 over 5 to get my theta. Now the problem is when I do that, I'm going to get a number, but I did not have a theta in my question. I had a t in my question. So if I do inverse cosine, that's going to give me all the inside stuff. So once I do that, if I do inverse cosine, I'm going to get 1.37. Again, make sure you're in radians mode. Okay, I'm going to erase this just because I'm running out of space here. So if you did it the other way, you would still get 1.37 equals theta, but you have to remember that you don't have a theta in the question. You had all that junk inside the red brackets. So now we're going to solve for all that junk inside the red brackets. So to do that, I'd multiply by 31. I'd have to divide by 5 pi. So if I actually do 1.37 times 31, I get 42.47. Okay, and then I have to divide by 5 pi. So I'm going to do that in my calculator. If I divide by 5 pi, again, make sure you know how to use your calculator. You might have to divide, if I do just divide by 5 pi, it divides by 5 and then times is by pi. So I have to put my 5 pi in brackets when I divide on my calculator. Or you might have to divide by 5 first, find what that is, and then divide by pi. So make sure you know how to use your calculator. I get 2.70. And then if I add the 7 to both sides, I get 9.7. So one of the times would be after 9 a.m., but before 10 a.m. You can figure out exactly. All right.